So this session is about simplifying radicals, and there are basically two things during the section. They're talking about the multiplication property and then also the division property, where you deal with things with fractions. I'm not going to go over fractions in this one. I'm going to show the rule, but I'm not going to do any examples of fractions because I have plenty of examples just for the multiplication property, and that's the one that you're going to see more often. So radicals, those are the things that basically use what is often called the square root symbol. The technical word is radical because it means more than the square root. It can be the cubed root, the fourth root, fifth root, and which root it is depends on the number that you have, or in the spot where I have labeled n. So that is called the index. And so we don't write a number there. We assume it's 2, but anything higher than 2, we'll write a number. And when you're entering it into the homework system, you want to make sure that you're up into that little box so that you put the number there when you need to, just when you come across this. Although I think in the homework system, you only have to do with square roots, and you're not doing anything more complicated than that. But they're basically two properties of things, and I'm going to use the word square root or phrase square root because that's what we're going to be looking at today. Basically, if you have two square roots and they're multiplied together, you can combine those under the same square root. And then you can also go the other way. So if you have things that are multiplied inside a square root, you can separate it out into separate square roots. And that works the same way for the division property, where if you have a fraction, so you have things divided inside a root, you can separate it out so that they're separate, one on top, one on the bottom. And these are the rules. These properties allow us to simplify square roots, simplify radicals, so that they're easier to work with. So what does it mean to simplify a radical? Well, we want to make sure that our number that's inside the radical symbol is as small as possible. So if there's any numbers inside, we want them to be small numbers. We don't want them to be large numbers. So we want to try to break them down. If there's any variables that have exponents on the inside of the radical symbol, we also want those exponents to be as small as possible. And then we want to take as much as possible and remove it from the radical so that it's on the outside instead of the inside. So when we're simplifying, we're basically trying to move things from the inside, take the square root or the cubed root, and remove it and put it on the outside so that the inside is as small as possible. So your goal is to make sure that all of your exponents that are inside are smaller than the index. So for a square root, you want your exponents to be just 1, or no exponent at all, and basically no variables at all. For cube roots, you're allowed to have things up to x squared, but you don't want to have anything higher than that. So if there was like a 9th root, you could have exponents all the way up to 8. So you need to just make sure it's smaller than what that root is. No radicals are in a denominator of a fraction, so we don't want any square roots in the bottom of a fraction. And we don't want any fractions inside a square root or inside the radical. So our goal is to separate those out. What we're going to be dealing with today is just the first one, just the top one, is making sure that anything that has exponents on the inside is smaller than the index so that we can simplify it. So I'm going to start with numbers, and then I'm going to start pulling in variables. But most of what you're going to be working with are numbers, especially when you deal with the quadratic formula. When we solve quadratic equations, we deal with numbers inside the square root. So when it says simplify, we want to take these numbers that are inside the square root and make them as small as possible. So the one on the left, I have 75. I want a number smaller than 75 inside there. And I want to take as much as possible to be on the outside. So the way that I do this is I make a factor tree. So the factor tree is what I do when I have fractions and I need to simplify fractions. I've used a factor tree for finding the common denominator, for finding the least common multiple, the greatest common factor. It comes up quite a bit. It's a very good skill. So I'm going to take the number that's inside the square root, and I'm going to make a factor tree. So I've got 75, and I need to split it up. And I know that 25 times 3 gives me 75, because I know that's the 3/4, basically. So 3 is a prime, so I can circle that. That I can't split up. And 25 is 5 times 5. So, and 5 is a prime number, so I can't split that up. So 75 can be split up as 5 times 5 times 3. So all of those prime numbers, we can rewrite 75 into the smaller numbers. So when we're simplifying, I'm going to have my square root of 75, and instead of writing 75, I have 2 5s, so that's 5 squared times 3. So I used my factor tree to do a prime factorization, and I've now split my 75 up so that I have smaller numbers. Because our goal is we want to have smaller numbers under the square root, and 5 and 3 are smaller, so that's good. Now the second thing that we need to do is we need to make sure that all the exponents are smaller than the root. So a square root means an index of 2, so that means I can't have any exponents of 2. I need to have them smaller. Basically, for a square root, you want no exponents at all. So we need to somehow get rid of the exponents. And we do that by grouping them in groups of 2, basically. In this case, I already have it grouped by 2. And this is because I can take a square root of something square. The square root cancels out an exponent of 2. So I'm going to use that property, group things in powers of 2, and then I can cancel things out. So what I'm going to do here first is I'm going to separate this square root into 2 separate square roots. So I'm going to use that multiplication property, where if you have things multiplied, you can split it up so that they each have their own square root symbol. So I have the square root of 5 squared, and then I have the square root of 3. Now, any square root of something squared, that automatically cancels. So the square root cancels out that exponent of 2 on the 5, and all we're left with is 5. Because 5 squared is 25, and the square root of 25 is 5. So those just completely cancel out, so I have just the 5. And then I'm left with the square root of 3. And at this point, there's nothing more that I can do because I don't have any more exponents to simplify. So this would be our simplified answer. So our goal is inside the square root, you have a number that's smaller than what you started with. So 3 is smaller than 75. And we put whatever we can outside of the square root symbol. So we were able to pull out a 5 because of that 5 squared. So we could take that square root and pull it out. And so now we have whole numbers in front, and we have fewer things to deal with in the square root. So that's simplified. So I'm going to do the same thing for the square root of 40 that I have here on the right. So I'm going to make a factor tree. So 40 is 4 times 10. And I can break each of those down. So 4 is 2 times 2. And then 10 is 2 times 5. So our prime factorization, we have the square root of 40 is equal to, and then we have 2 times 2 times 2. So we have 3 2s, so it's 2 to the 3rd power times 5. So in order to simplify this, so right now we've got something that's 2 to the 3rd. We want to put these in groups of 2. So 2 to the 3rd has 3 things grouped together. We want to group it in powers of 2. So instead of writing it that way, I can rewrite this as 2 squared times that third 2 just kind of off to its side, and then the 5. So just instead of just counting all the exponents, I can split it up so it's in groups of 2. And we do this because the square root cancels out exponents of 2. So I want to try to group as many exponents of 2 as possible. So I'm grouping them all in pairs. So once you've split that up, now we're going to use that multiplication property where we split our square root up so that it's multiple square roots multiplied together instead of the multiplication inside. Now when we do this, we only split up the things with the exponent of 2. So I'm going to split up the square root of 2 squared, and then I'm going to keep the 2 times 5 together because those don't have any exponents of 2, which means I can't simplify those further. So those are just going to have to stay grouped together. So the only things I can simplify are things with an exponent of 2 for a square root. So now I have the square root of 2 squared, and that square root and the exponent of 2 cancel. So I'm left with just the 2 that's underneath, just the base of 2. And then I have my square root of 2 times 5, which we will multiply together. So that gives us 10. And this is the simplified form. So inside the square root is 10, which is smaller than 40, which we started with. And then we were able to pull the square root of 4 out, which becomes 2. So now we have a whole number outside there. Are there any questions? Okay, so I'm ramping it up a little bit. Again, we have square roots here, but I have numbers in front of the square roots to show you what happens if you have that number in front. What do you do with the whole thing? So I'm going to start with 20 times the square root of 27. So I'm going to make my factor tree, and it's only going to be what's inside the square root. So that's going to be 27. So 27 is 3 times 9. 3 is prime, so I can circle that. And then 9 is 3 times 3. So I'm going to circle those. So I have 20 times the square root of 27. And I'm going to be rewriting the square root of 27. So we have the square root, and that means we want to group these in pairs because it's a square root. We want to group them in things that are squared. So if I have 3 3's here, I can group 2 of them together and then leave the third one by itself. So instead of writing it as 3 cubed, I'm pairing them off. So I get 20 times the square root of 3 squared times 3. Now I'm going to separate out my square root symbol. I'm going to take the thing that's squared and separate it out from what's not squared. So I'm taking that multiplication on the inside and turning it into multiplication of square roots. So I have 20, the square root of 3 squared, and then the square root of 3. So I have 20. Now this is all multiplication. So when I take the square root of 3 squared, the square root cancels the exponent of 2, and I'm just left with that 3. And then I have my square root of 3. So I've got 20 times 3 times the square root of 3. And then we multiply those whole numbers together on the outside. 20 times 3 is 60. So we get 60 times the square root of 3. So I was able to pull out the square root of 3 squared, or the square root of 9, take that square root to give me 3, and then I could multiply it on the outside instead of leaving it on the inside. On the right here, I've got a negative 11 times the square root of 8. So again, we're going to do something similar. We're only going to make a factor tree for what's inside the square root symbol. So that's 8. So 8, 4 times 2. And 2 can't be broken down, so I circle that one. And then 4 is 2 times 2. So I'm going to circle those. So I have negative 11 times the square root of 8. I'm rewriting this as negative 11 times the square root. And then again, I'm going to group these in pairs. So I have 2 times 2, which is 2 squared. And then I have a third 2 left over. Now, just like on the left, I'm going to take the multiplication inside the square root and turn it into multiplication of square roots. So that I have the square root of 2 squared times the square root of 2. And then I have that negative 11 still in front. So I've got negative 11 times, and then the square root cancels out the exponent of 2, which leaves me just a whole of 2, the base, what's underneath it. And then I have my square root of 2. And then I multiply negative 11 times 2, so that gives me negative 22 times the square root of 2. Are there any questions? Okay. So now that we've seen this with numbers, let's take a look at variables. So I'm not going to throw in the numbers and the variables at the same time. Let's just focus on the variables, and then we'll do both of them together. But I want to make sure you see examples of what you do just when you have variables. And variables are actually almost easier to work with because you don't need to make a factor tree at all. All you're doing is trying to group things in groups of 2 for a square root. If it's a cubed root, you'd be grouping them in groups of 3. So let's take the first one on the left. We have the square root of b to the 9th. So we think when we have variables, b to the 9th is literally multiplying 9 b's together. Hopefully I have enough room here. And whenever we have things multiply together, for it to cancel out the square root, we need an exponent of 2. So we're going to be grouping these in groups of 2 so that we can write them as b squareds. So I have the square root of b to the 9th, and I can rewrite this as b squared times b squared times b squared times b squared, and I'm going to times that last b. So I've got 4 groups of 2, which gives me 8 b's total, and then that 9th b is by itself. So anything that has this exponent of 2, we want to write it out by itself, separate all of those multiplications. Now, this problem is, you can skip a lot of these steps once you understand the process. I'm going to show everything so you can see how it works. So I just separated out those 4b squareds and then the square root of b by itself. Now, every square root of something squared, those cancel, so I'm left with b underneath. And then I have my square root of b that I can't cancel. And so now I have 4 b's multiplied together, which gives me an exponent of 4. So I get b to the 4th and then the square root of b. Now, a quicker way to do this, and which is usually how I do it once you understand the rules, is to try to group your exponents as multiples of 2. So I had those 4b squareds together. If you multiplied those all together, that would give you an exponent of 8. So I would just, instead of splitting it up in pairs, I would split it up as something that I can divide by 2 and then whatever's left over. So 9 becomes 8 plus 1 more to give me 9. And then I have that b to the 8th power. And then I would separate my b to the 8th times my b. Now, I said this, the square root cancels out things squared. Another way to think about it is that it divides the exponent by 2. So an exponent of 2 divided by 2 is 1, and that's why the b's have no exponents when they leave the square root, because the square root basically divided that exponent by 2. So using that same thought, to take the square root here, I would divide the exponent of 8 by 2, which gives me 4, and then that's how we get b to the 4th times the square root of b. So that is a quicker way to do it, especially on the problem to the right where we have the square root of w to the 22nd. You don't want to write all of those out. That would be a lot of them. If I wrote out all the pairs, there would be 11 of them. But instead, we can use this shortcut. So I have the square root of w to the 22nd. And the rule is, now this is an even number, I can divide 22 by 2. So you want to make sure it's grouped in things that you can divide by 2 because it's a square root. And if you can, then you just take the square root by dividing the exponent by 2. So 22 divided by 2 is 11. So that removes the square root by dividing the exponent by 2. And our answer is w to the 11th. Are there any questions? Okay. So more variable things. Now I'm combining with multiple variables. But the rules are basically the same. We're going to try to, these are all square roots, so we want to separate it out so we make sure that our exponents can be divided by 2 so that we can remove them from the square root. So the first one I have here is c squared d to the 9th. So c squared, that exponent of 2 is perfect. We can take the square root, that's fine. But the d to the 9th is a problem. We can't divide 9 by 2. So we want to do what I did on the last problem. Make my square root longer. We have our c squared. And instead of writing d to the 9th, I want d to the 8th and then a leftover d. so that I still have 9 of them there. I'm just rewriting it. So now anything that has an even exponent that can be divided by 2, which allows me to take the square root, I'm going to separate those out into separate square root symbols. And then whatever's left over just goes into a third square root. So I have the square root of c squared times the square root of d to the 8th times the square root of d. So these are all multiplied together. Then to remove the square root, to basically take it outside of the square root, you divide the exponent by 2. So that leaves me with a c, because the square root and the 2, those cancel. Then 8 divided by 2 is 4, so I get d to the 4th, and then I have my leftover d. And then we usually just write this combined without the multiplication symbols. Whoops, I don't know why I write 5 instead of a d. That makes no sense. So that becomes c d to the 4th times the square root of d. So all you really need to know is your multiplication and division tables, and you just need to know that to group things in even numbers for a square root. So on the right, I have v times the square root of u to the 10th, v to the 7th. So u to the 10th, I can divide the exponent of 10 by 2, so that's okay. V to the 7th, I need to rewrite. So I'm going to rewrite this as v on the outside, and then I still have my u to the 10th. And I'm going to do v to the 6th times v. So I still have 7 of them there. I just took one away and moved it separately so that I can divide it by 2. So I can divide that exponent by 2. So now I'm going to split up my square roots. I have that v in front. Then I have my square root of v to the 10th, my square root of v to the 6th, and then the square root of v. So I have v. Now I'm going to actually take the square root, which means dividing the exponent by 2 to get it outside. So 10 divided by 2 is 5, so that gives me u to the 5th. And then 6 divided by 2 is 3, so that gives me v to the 3rd. And then I have my leftover v. Now I want to recombine and put these together. Now I have 2 v's here, and we usually write these in alphabetical order. So I'm actually going to put the u to the 5th first, and then I have a v times a v cubed, which when you multiply those, you get v to the 4th, and then I have my square root of v. So you need to recombine anything that's on the outside that may be able to be multiplied together so that you have a single exponent there. Are there any questions on either of these two? Okay. Now let's start combining the numbers with the letters. That's how we naturally go as we get more complicated. So on the left here, I have a -4, and then the square root of m to the 8th, n to the 4th. So we're going to just follow the same rules we've been doing. So first, I'm going to just rewrite the problem, just write it down again. So in this case, when I'm looking at it, inside the square root, I already have things with exponents I can divide by 2. Because I can divide 8 by 2, I can divide 4 by 2, so I don't have to do any rearranging of the stuff on the inside. I can go straight to splitting these up into different multiplications. So I'm going to have -4 times the square root of m to the 8th, and then times the square root of n to the 4th. And now I'm going to actually take those square roots. So I have my -4 in front, and then m to the 8th. To take the square root, you divide the exponent by 2, so that gives me an exponent of 4. So I have m to the 4th. And then on the n, 4 divided by 2 is 2, so the exponent is 2. And we're left with nothing left in a square root, though everything came out of the square root. So when we write this, we have -4 m to the 4th n squared, and that is simplified. So we end up with nothing inside the square root at all. We were able to take that square root and make it simpler. Now, on the right here, I have the square root of 27y to the 5th. So once you start having numbers inside the square root, you need to do your factor tree again. Now, we've already done a factor tree for 27, and we actually already simplified that one. For this left problem, we had the 27, and we simplified that. And we rewrote it as the square root of 3 squared times 3. So I'm going to do the same thing. I'm not going to show the factor tree because I already did it here, but that's what we're going to do. So start by my square root of 27y to the 5th. And from the previous slide, 27, we can split up as 3 squared times 3. And then we have this y to the 5th. So that has an exponent of 5. We want it divisible by 2, so I'm going to make it an exponent of 4, and then I have the y left over so that there's 5 of them total. Now, usually when you have something like this, what we'll do is we'll rearrange inside so that everything with exponents that are we can take square roots of, basically all of those even exponents, we're going to put those in front and put the other stuff after it. And this just makes it a little bit easier for us when we are simplifying. So I'm just rearranging so the exponents are going first. So now I'm going to separate my square roots. So I have the square root of 3 squared. Then I have a square root of y to the 4th. And then the 3y is going to be under a single square root because that's not going to be able to simplify. So I'm going to just stick those together. And now I'm going to simplify each of these square roots by dividing the exponent by 2. So the square root of 3 squared gives me 3. The square root of y to the 4th, 4 divided by 2 is 2, so we got y squared. And then I have my square root of 3y. So we just rewrite this without our multiplication symbol and put everything together. We have 3y squared times the square root of 3y. And you want to be very careful that you have your square root symbols properly over everything that's inside the square root so it doesn't get confusing. So you want to make sure that your lines are long enough and things are inside when they're supposed to be inside and outside when they're supposed to be outside. Generally, I always put anything outside supposed to be in front, so that way it's easy to tell what's inside and what's outside because it could get a little confusing otherwise. Are there any questions on these? Okay. Now these are my last two. And of course, they're more complicated. So I have on the left, we have 3 outside the square root. Then we have the square root of, and all of this is inside, 88, n to the 4th, n to the 11th. So first thing is I'm going to take the number that's inside of the square root and do the factor tree. So I'm going to do a factor tree for 88. So I know 88 is 8 times 11, and 11 is prime, so I'm going to circle that. Then 8 is 4 times 2, 2 is prime, and then 4 is 2 times 2. So rewriting this, I have 3 times 88. If I write the original, n to the 4th, n to the 11th, made my square root symbol too long. And now I'm going to rewrite this with all of my exponent stuff. So I'm grouping these in 2 because of the square root. So the 88, I've got 3 2's, but I'm going to group them as 2 of them and then put the third one by itself. And then I've also got that 11, so I have to put that also in there. So you want to make sure you're not forgetting anything. M to the 4th, so that exponent's okay. That's 4 I can divide by 2. And then we've got n to the 11th. So 11 is not okay. I can split that up as n to the 10th and then another n. So I've got lots of things going on here. I'm probably actually going to run out of room. I should have put these each on their own slide with how long they're getting. You know what? I think I'm going to do that. I am going to temporarily stop sharing so I can add an extra slide for that second one. Just that way we don't have to try to smush it. So let me just do that. And then we'll remove this. Oops. Oh no, things moved and I didn't want them to move. Okay, now that I've fixed that, let me share my screen again. Okay, so I'm going to just put these all in the same, I'm going to, instead of putting it all the way in the bottom there, oops, I'm going to move what I've written up to the top so I have more room here. So I have 2 squared times 2 times 11 n to the 4th times n to the 10th times another n. So I'm going to just, oh, it's not letting me erase the stuff I already wrote. That's okay. I'll fix that later. Okay, so I'm trying to give myself more room here. I can't erase what I already wrote. I'm going to rearrange everything with an exponent to front again. And I'm actually just going to change colors here so it doesn't get confused with what I wrote earlier. So I'm going to have big, long square root symbol. I've got my 2 squared with an exponent, m to the 4th with an exponent, n to the 10th with an exponent, and then the stuff without an exponent is 2 times 11 times n. So now everything that has an exponent I'm going to separate out into its own square root symbol. And then everything that does not have that exponent is going to be stuck in the same square root. So I've got 3 times the square root of 2 squared times the square root of m to the 4th times the square root of n to the 10th times the square root of 2 times 11 times n. Now, everything that has a square root and an exponent that's even, I can simplify. So the square root of 2 squared is 2. Square root of m to the 4th, so you divide your exponent by 2, and that's m squared. The square root of n to the 10th, 10 divided by 2 is 5, so that becomes n to the 5th. And then inside my square root, I'm going to multiply 2 times 11 to get 22n. And now I'm going to simplify these all to the final answer. So I can multiply the 3 times 2 together, which is a 6. And then I have my m squared, my n to the 5th, and then my square root of 22n. Oops, that was a really terrible straight line for boxing purposes. And that is the final simplified answer. So we were able to remove as many variables and stuff from the inside as we could. We got the 88 down to a 22, and we're able to pull things out so they're in front, which are easier to work with. Are there any questions? Okay. Last one here. This is the one that I had that I moved over. So that's a negative in front. And then we have the square root of 18x y to the 4th z cubed. So I'm going to start with the 18 that's inside the square root, and I'm going to make a factor tree. So 18 is 9 times 2. 2 is prime. And 9 is 3 times 3. So we have negative square root of 18x y to the 4th z cubed. And then I'm going to make sure my square root symbol goes above all of that. And now I'm going to have, oh, I can't forget my negative sign. That would be really bad. My negative, and then I'm going to have a long square root. So 18, we broke it down. We've got 3 times 3 times 2. So 2 of those 3's I can group together to be 3 squared. And then I have that 2 from the prime factorization. Now I move on to the variables. I have x, so that's just has no exponent. I can't do anything with that. Y to the 4th, that I can divide that exponent by 2, so that will be okay. And then I have z cubed. So the 3 is not okay. I can't divide that by 2, so I'm going to split that as z squared, and then my leftover z, so that there's still 3 of them there. So next line, I'm going to move everything with that exponent to the front of my long square root symbol. So I've got 3 squared, y to the 4th z squared, and then the things without the exponents are 2x z. So I'm just grouping those. And now everything with an exponent is going to get its own square root symbol. So I still have that negative in front. I have the square root of 3 squared, the square root of y to the 4th, the square root of z squared, and then the square root of 2x z. And I deliberately write my z's the way I do so they don't get confused with 2's. And now I'm going to take these square roots. So I have my negative. The square root of 3 squared is 3. The square root of y to the 4th is y squared. The square root of z squared is z. And then I have the square root of 2xz. And then that is our simplified expression there. Are there any questions on this example? All right, so that was the last example that I had. You may be wondering, well, why do we have to learn how to do this? You know, where is this used? So if this is your only math class that you have to take, really what you need to know is how to simplify square roots involving numbers only, because that's used for the quadratic formula. And if you're going on to business, you often use the quadratic formula. If you have to take a physics class, you often have to use a quadratic formula. So those are very helpful skills, is being able to simplify just when you have numbers. If you have to move on to college algebra, you're going to do this again. So of course, you're going to need to make sure to know how to do this for college algebra. But the stuff with the variables is very helpful for other types of math, like when we get into pre-calculus, you get into calculus, and then you get into engineering things. So it kind of, I don't know how much of this you need to really remember after this class depends on where you're going next. Just basically understanding square roots in general is good for all students, no matter what you're doing. But the ones in particular that may need to know this are those going into anything that uses quadratic formulas. I think actually quadratic formulas and square roots are used in criminal justice. So that actually, those in that field, I think your skid mark formula for accidents uses it. So that's another reason where you need to know how to simplify these kind of things, is for that formula as well. But even if you're not going to be using square roots, just understanding the thinking process and how else can I rewrite this? You know, is there another way to look at this that makes it easier for me? Which is what we're doing when we're trying to simplify these, is we're rewriting those things with different exponents and making them easier to work with, things that we can simplify. So that thinking of what's another way to write this is really good skill and can apply as another, you know, what's another way that we can do this? What if we looked at this differently? Would that make it easier? That kind of thinking process is good for everyone, even if it's not necessarily related to math. It's got a lot of that, just the logical thinking and the looking outside of the box to see what you can do with things is a good skill to have. So that's what I've got for you guys. I hope that this is helpful. You didn't have any questions, so I'm hoping that means that it made sense and everything. I've seen thumbs up, so that's good. That's good. So that's what's important. And really, most of the stuff you're going to deal with the rest of this class are just dealing with the number portion. So if that's even, you know, the variable stuff is not too bad. But if it's like, as long as you can do the number portion, you'll be okay. So, all right. Well, thank you guys for joining. I appreciate it. I'm glad that you were able to attend. I will make sure to get this out tomorrow morning, so that way you can reference it again as you do the homework. And I have tons of other videos in the video section on the quadratic formula and all that kind of stuff. So watching those would be very helpful as well to help you out. So, all right. You guys have a great night. Wonderful evening. Hopefully you have a great weekend, since tomorrow's Friday. I'm going to say that's close enough to the weekend. You know, enjoy yourselves. And I will talk to you guys later. Bye.